Would we like to have an objective biomarker of pain? Would we like to have an objective means of determining, is somebody in pain? Can we predict whether somebody will respond to a specific treatment, whether before an injury or surgery, whether that person will go on to get persistent pain or use opioids persistently? And of course the answer is yes. And so what my session was all about was giving both a historical perspective on this and where we've been in the field of brain imaging and opening up windows into the brain, allowing us to perceive where pain is processed, where it's perceived, and how it becomes this incredibly subjective and unique individual experience. And then as we've moved forward over the last 10 years into translating that knowledge into the development of what we hope will be an objective biomarker of pain. Now, I led the audience through the development of this technology as a diagnostic marker, which is the work that we and others have done to determine, is somebody in pain or not in pain? And candidly, as I mentioned to the audience, I don't find it a very interesting question. I think it's a quite boring question, because if I want to know if somebody is in pain, I'll simply ask them. They're sitting in front of me in the clinic, I'll just ask them if they're in pain. But the thing is, we have to start there. We have to walk before we run when we're trying to advance this technology. So we've started off with these diagnostic markers of pain, and now the field is moving towards the development of more of these predictive biomarkers and prognostic biomarkers. Ultimately, the holy grail of this is to combine brain imaging biomarkers with inflammatory markers, with genetic markers, with others, to be able to determine for a particular patient in your clinic what is the right treatment for them under these particular circumstances. Objective biomarkers of pain, or a journey down the rabbit hole. So, why did I frame it that way? Because this is actually an incredibly controversial area. And it has huge implications from the science community, the legal community, and the ethical community. And there is the overriding question, first of all, can we actually capture that thing which is so subjective and make it more objective? And if you'd asked me 10 years ago, I would have said no, absolutely not. There's too much individual variance or variability in all of our experiences. But as time has gone by, I've evolved my opinion to be now emphatically in the camp that we are going to develop excellent objective biomarkers. They're not going to be perfect, but I think they're going to help us in guiding treatment decisions, which is the most important thing. But there's a lot of controversy that remains in the research field over whether this can be done or can't be done. So everybody by now has heard about machine learning. It is everywhere in society. What we've done is we've taken that type of approach to advanced statistics and applying it in neurosciences. And where it is particularly important as prediction machines, because the way we've been approaching, for instance, brain imaging all in the past, is we apply more traditional statistic methods. And in this case, what we're simply trying to do is determine, is this person who we know is in pain, does their brain look different from this person who we know is not in pain? And so we apply simple statistical models, t-tests, and we see if there is a difference. Well, the problem with that is that it doesn't give us the ability to discriminate between these two groups if we don't have any information ultimately about them. And let me give you an analogy to illustrate. Let's take height in the United States of men and women. So if we take height, and we know that the average man is, I believe it's 5'10", the average woman is, I believe it's 5'3", and if we apply a statistical t-test to that on a population means, we're going to have a p-value with a cajillion zeros followed by some digit. It's incredibly statistically significant. We get that. However, if I present you with a person that you can't see or know anything about other than I've told you that they're 5'8", can you tell me if that's a man or a woman? And the answer is no, because I haven't given you enough information to discriminate that. And so that's where the machine learning comes in. We feed the machine learning features, descriptors of that person, and we develop an algorithm from that that can fit all that information into a model that defines whether it's a man or a woman. And then what you do is you go validate it, because you can't just rely on the test group. You have to actually go grab a bunch of people and who are fresh and then test the system out to make sure that it's really working. So that's an overly simplistic but I think useful view of machine learning and how we're applying it. And the field is just absolutely exploding with new algorithms and new approaches, and I see it transforming what we're doing. Now let's move into the legal field. In the legal field, the attorneys and judges have wanted for years a way of objectively determining whether somebody who has brought a lawsuit or is on workers' compensation is faking it, or do they have real pain? And I originally got involved in this space because of a medical legal case. And while there's strong pull from the legal community to bring this technology in, both myself as well as others in the field have been adamantly opposed to using this in the courtroom because we feel it's incredibly premature and it would be a misuse of the technology. On the ethical standpoint, there's all sorts of ethical dilemmas here that we're going to have to face. If we have an objective way of determining if somebody is pain or not in pain, can it be misused or abused to deny them treatment, to invalidate their pain? That would be terrible, that would be tragic. Is it going to be used by insurance companies to deny treatment for a particular person? So we have to be very careful about how this is used. If anybody has seen the movie Gattaca, which took the same theme I'm describing around the ethical issues, but it was applied to genetics and how genetics in an advanced, in the future society use this to determine who would have a particular status in society. One could imagine this technology being applied in much the same way. So what does that mean? That means that if we're going to successfully navigate this, we need lots of smart people looking at this problem from a variety of different perspectives, all coming together and deciding, what is the right way to proceed from a scientific standpoint and its use in the legal community and the ethics around this issue. So we all want to identify targets for therapeutics, whether those targets are drugs, mind-body approaches that are targeted, neurostimulation approaches like transcranial magnetic stimulation, other mind-body approaches. And we're aided if we know where we're targeting, what we're targeting. Are we targeting a certain brain region, a certain brain network? And so where the neuroimaging is leading us, and particularly in this area of brain-based biomarkers, is not only the ability to detect and predict and prognose a person, but also to ideally identify targets for future intervention. Again, targets that we may manipulate through transcranial magnetic stimulation, which we do in our lab, or through the others that I just mentioned. So that's another exciting offshoot, if you will, of this technology and where I think there's got great success for the future. It's both an exciting and a somewhat scary scientific development. There's so much incredible potential, and there's also significant potential for misusing and abusing this technology. And I think that the best way forward is for, once again, bringing a lot of people to the table, all who are stakeholders in different ways. And let's have discussions about this. And let's find a common path forward where we are both developing this exciting technology, but making sure that we're using it in a responsible manner.